This is solving quadratic equations, pre-assessment. There are 4 different parts. You'll notice that I put them in parts on how to solve quadratic equations. Let's do this. The first one technique is through factoring. And when we factor, we create 2 boxes and factoring, and we're using the multiplication property of 0. Prop of 0, because we know one of these boxes needs to be 0. The second technique is isolating the variable and taking the square root. The third technique is going to be completing the square. And then taking the square root. And then the fourth one is the quadratic formula. So you need to be proficient at all 4 techniques. I'm going to mandate that you use each one. And you can't use the other, so you're going to have to do some difficult ones when completing the square. That's really the only one, and yeah, 3 is really going to be the most technical one. So we have 2 boxes that equal 0. This is already factored, so either this box is where the 0 is coming from, or this box is where the 0 is coming from. So what we do is we find out what value for x when it's being subtracted from 8 equals 0, and which value when multiplied by 5 and added to 8 equals 0, and then we just solve for the variable. So we use the inverse operations. So when x is 8, that is a solution because it'll make this box equal 0, which will multiply to make 0. You subtract 8 from both sides, divide by 5, you get x equals negative 8/5. So when x is negative 8/5, this box, this quantity becomes 0, making this product equal to 0. Yes, I know this doesn't make 0, but because this is 0, it doesn't matter what this value is. And then when we write our solutions, I want the solutions in numerical order. I will minus points off if you do not do that. And we put them in solution sets. Now we see that they didn't give it to us factored, so we go through our little factoring things. 1a is set equal to 0. 1b, is it in standard form? 2, is there a common factor? 3, is it a special case, not a binomial square? And 4, a times c. So my a is 1, my c is negative 12, equals negative 12. 1 times 12, 2 times 6, 3 times 4. The signs are different, and the bigger is negative. So the bigger is negative. These are all the bigger factor pairs. These are all the smaller factor pairs. This gives us negative 11, negative 4, negative 1. Negative 4 is my middle, so I'll use these 2 terms. N squared plus 2n minus 6n minus 12 equals 0. We're going to group these 2 and group these 2. We'll factor out an n. We'll get n plus 2. We'll factor out a negative 6. Notice my first term is negative, so I need to factor out a negative 6, leaving me with n plus 2 equals 0. Just multiply it back out to make sure that you get those 2 values, which we do. And also notice that these 2 quantities are the same. We'll factor out the n plus 2, leaving us with n minus 6 equals 0. And now we have 2 products equaling 0, so one of these must be equal to 0. What value for n would make this 0? What value for n would make this 0? Subtract 2. Add 6. And my solutions are -2, 6. Remember, 1a is set equal to 0. So let's add 8. N squared minus 6n plus 5 equals 0. It is not, it's in standard form. There is no common factor. It is not a special case, so I will do a times c, which is 1 times 5, which equals 5. Factors of 5 are 5. Signs are the same. Both are negative. Gives me my -6. N squared minus n minus 5n plus 5 equals 0. Factor out an n. Factor out a -5. N minus 1, n minus 5. N minus 1 equals 0. N minus 5 equals 0. Add 1. Add 5. And we get 1, 5. Set it equal to 0. We're going to subtract 2, subtract k, subtract 2, subtract k. My k needs to be, or my k squared, no, not k squared. My a value, a must be positive. When factoring, it doesn't have to be 1, it just needs to be positive when we're factoring. And we're using the factoring technique for all of these problems. So just keep that in mind. Equals 0. It's in standard form. There's no common factor. It's not a special case. So I will do a times c. 1 times -2. Signs are different. Bigger is negative. So we get k squared plus k minus 2k minus 2 equals 0. Factor out the k. Factor out the -2. K minus 2. K plus 1 equals 0. K minus 2 equals 0. Plus 2. So my solutions are -1, 2. So it's set equal to 0. There's no common factor. It is not a special case. So we will do a times c. 5 times -6 is -30. 1 and 30. 2 and 15. 3 and 10. 4 no. 5 and 6. Signs are different. Bigger is negative. Could have switched it up and made it a little bit more interesting, making one of them positive. Just noticing that they've all been negatives. This is my middle. So we have 5n squared plus n minus 30 n minus 6 equals 0. Factor out an n. 5n plus 1. Factor out a -6. 5n plus 1. 5n plus 1. N minus 6 equals 0. 5n plus 1 equals 0. N minus 6 equals 0. Minus 1. Divide by 5. Add 6. -1/5, 6. are the two solutions. Set equal to 0. 6r squared minus 2r minus 4 equals 0. There is a common factor. So set equal to 0. Standard form. There is a common factor. There's a common factor of 2, leaving us with 3r squared minus r minus 2 equals 0. It's not a special case, so we'll do a times c. 3 times negative 2 is negative 6. 1 and 6, 2 and 3. Signs are different. And bigger is negative again. Sorry. Not very creative. Negative 1 is my middle. So 2, 3r squared plus 2r minus 3r minus 2 equals 0. What are we going to factor out? We're going to factor out an r, giving us 3r plus 2. We're going to factor out a negative 1, leaving us with 3r plus 2 equals 0. 2 times the quantity 3r plus 2, r minus 1 equals 0. Now we have 3 numbers that are being multiplied to make 0. We know what this number is inside this box. There is no variable, so this is a constant, so we know this is not where the value becomes 0, because this is a 2. So our only choices where it could be 0 are with the variables. So we set each of the quantities with variables equal to 0 and then solve. That's one of the solutions. This is the other solution. 2 is not a solution. 2 will not make it 0. 2 is the constant, so please don't include 2 in your solution sets. The only 2 solutions are negative 2/3 and 1. I like this problem. Set it equal to 0. We get 5p squared plus 7p equals 0. So 1a, set equal to 0. 1b, make sure it's in standard form. 2, is there a common factor? Yes, there's a common factor again. P, leaving us with 5p plus 7. That can't be factored any further. We have two boxes multiplying to make 0. Set each one equal to 0. That's the value that makes that box 0. And this value. So our solutions are negative 7/5, comma 0. I like that one. That's a horrible solution set right there. Let's try to make that a little bit better. Not much better. All right, part 2, you must solve each equation by taking square roots. So we have to isolate the squared value. And what gets rid of a square is a square root. Yes, so we'll take the square root. Whenever we take the square root of a variable being squared, we must introduce plus minus, because the plus value squared and the negative value squared will give you the same solution, same product. So square root and a square cancel, leaving us with x. Now 50, rad 50 can be broken up to rad 25 times, that's not a 2, times 2. So we can separate radicals being multiplied, and 25 is a perfect square. So I chose that. Why didn't I choose 5 and 10? Why didn't I choose rad 5, rad 10? Because neither are perfect squares. Rad 25 is a perfect square. That's why I chose that factor pair. So we get plus or minus 5 rad 2. That would be the answer. So let's isolate. We need to isolate our radical, or our squared value. Our squared value, again, has to be positive. A must be positive. Oh, well, actually, we're just isolating A. Let's do that. That's better. Isolate x squared, your squared value. Not A, isolate A. We have to get rid of A. X squared is going to give us, what's that, 81. We'll take the square root. Whenever we take the square root of a squared value, we introduce plus or minus. Square root and a square cancel, equaling plus or minus 9, because 81 is a perfect square. This is a two-step equation. We're going to subtract. Now we're going to divide. We get 25. We've isolated our squared value. We're going to take the square root. We get m equals plus or minus 5. Did I not do it in solution sets? I don't think I did it in a solution set. I did not. And that means, well, we'll go back to this one. This means plus or minus 5 rad 2. It's just a more efficient way of writing two solutions. Okay, that's isolating, that's solving by taking the square root. Part 3, that was pretty quick, part 2. Part 3 is you must solve each equation by completing the square. So step 1 is move your constant. No, sorry. Step 1 is set equal to 0. No, it isn't really set equal to 0, is it? It's really move your constant. Because set it, well, I don't want you moving the constant over and then moving it back, so I'll say move the constant. Move your constant. Technically, it should be set standard form. No, not even standard form. Let's move the constant. You get p squared plus 4p equals 32. Step 2 is take half. You're going to complete the square. And you complete the square by taking half of your b value and then squaring. So half of your b value is 4 divided by 2, and then square that value. So 2 squared is 4. We're going to add that to both sides to keep the equation balanced. Now, step 3 is create your binomial square. So your binomial square is going to be half of your b value, quantity squared, and that gives us 36. Now, step 4 is square root. Solve by taking the square root. By square root. So we'll take the square root of both sides. Whenever you take the square root of a variable being squared, you do plus or minus. This is p plus 2 because the square and the square root cancel. Plus or minus 6. Now we're going to isolate the variable by getting rid of the positive 2. And this is negative 2 plus or minus 6. That produces two statements. You have negative 2 plus 6, and you have negative 2 minus 6. This negative stays negative 2 in both situations. The only thing alternating is the 6. It goes positive 6 and negative 6. We want both situations. giving us 4 and negative 8. And then I need to put my answers in numerical order. So we're going to move the constant over. X squared minus 8x equals 8. Now we're going to complete the square by taking half of my b value and squaring. That's negative 4 squared, which equals 16. We will add 16 to both sides. This produces a binomial square. We take half of our b value equals, what's that, 24. We'll take the square root. Take the square root. This gives us x minus 4 equals, now square root of 24, I can simplify that to rad 4 rad 6, which produces 2 rad 6. So that's plus or minus 2 rad 6. Let's add 4 to both sides. And that gives us x equals 4 plus or minus 2 rad 6. I cannot add 4 and 2. Very important. This is where a lot of students make the mistake. They write 6 rad 6 and 2 rad 6. That is incorrect. These are unlike terms, so we leave it as 4 plus or minus 2 rad 6. That is the answer. That's the exact answer. All right. My constant's on the wrong place, on the wrong side, so I'm going to move that. My b value needs to be over on this side with my variables. So n squared plus 16n equals negative 55. I'm going to take half of 16 and square it. 8 squared is 64. So let's do 64 to both sides. This becomes n plus 8. Quantity squared equals, I think that's 9. Good. We'll take the square root. That's n plus 8 equals plus or minus 3. We'll subtract 8 from both sides. N equals negative 8 plus or minus 3. Let's write both of those situations. Negative 8 plus 3. Negative 8 minus 3. That gives us negative 5. This gives us negative 11. Numerical order, negative 11 is smaller than negative 5. Let's move this. This is a good one. Do we move it before? I guess it doesn't really matter. We need our a value needs to be 1. When completing the square, a must be 1. So let's divide first. It'll be fine. Divide everything by 5, giving me r squared minus 2r minus 8 equals 0. Now we'll set it equal to 0. We'll move our constant. R squared minus 2r equals 8. Let's complete the square. Half of 2 squared gives us negative 1 squared, which is 1. So we'll add 1 to both sides. This becomes r minus 1 quantity squared equals 9. We like that. We see the perfect square. And that's because we are so well versed at this point. R minus 1 equals plus or minus 3. Add 1. R equals 1 plus or minus 3. 1 plus 3. 1 minus 3. 4. Negative 2. My solutions are negative 2 and 4. Nice and efficient, fast. All right. I'm going to move the constant first this time because I don't want two fractions here. So 3r squared minus 12r equals -9. Let's divide everything by 3. Doesn't matter whether you do it first or second, but you definitely have to at some point. R squared minus 4r equals -3. Let's take our b value, take half and square. Add 4 to both sides. R minus 2 quantity squared equals 1. We like that. R minus 2 quantity squared equals plus or minus square root of 1. R minus 2 equals plus or minus 1, add 2. R equals 2 plus or minus 1. 2 plus 1, 2 minus 1, 3 and 1. Numerical order is 1, 3. So we're noticing that even though they get complex, now, as I say this, we're about to get into some fun, it should be taking you 60 seconds. It really does. If you've done enough of these, you get the routine of it. M squared plus m equals 42. Now my b value is 1. I take half and square. That's 1 squared over 2 squared. 1 squared is 1, 2 squared is 4. So I'm adding 1/4 to both sides. Okay, now we got to be proficient at fractions. This isn't hard. This is just half my b value. Now this shouldn't be hard. 42 over 1 into fourths, so I can have a common denominator. I'm going to multiply by 4, which gives me 168. So 42 is 168 fourths plus 1/4. So that gives me n plus 1/2 quantity squared equals 169 fourths. That shouldn't scare you. You have a calculator at your disposal during the test. So this should not be a big concern. Do not write 169 divided by 4 and then take the square root. You could, but understand, please be cognizant that we can separate these radicals and that they are perfect squares, 13 over 2. So m plus 1/2 equals plus or minus 13 halves. Using decimals is going to tell me that you don't understand. Showing your work and doing the work correctly shows me that you comprehend the material, that you understand it completely. -1/2 plus 13 halves, -1/2 minus 13 halves. That gives me 12 halves, which simplifies to 6. This gives me -14 halves, which simplifies to -7. And my solutions are -7, 6. Try not to use calculator. 169 we should know. And if you want to check it, that's fine. You want to go on here and check 169 square root. I have no problem with that. That equals 13. Check it. But don't start doing all of the work with a calculator. Use the calculator as a checking mechanism. We're going to set it equal to 0x squared plus 9x. My handwriting is deteriorating at 6:47 a.m. -10. So 9, let's take half and squared gives me 81 fourths. So we're going to add 81 fourths, add 81 fourths. This is the easy part. X plus 9 halves, quantity squared equals, Now we're going to make this into fourths. That's negative 40 fourths plus 81 fourths. X plus 9 halves squared equals, that's 41. 41 fourths. How ugly is that? That's not so pretty. 9 fourths quantity squared plus or minus square root of 41 fourths. So square root of 41 fourths gives me the square root of 41 over the square root of 4. Square root of 41 cannot be simplified. Square root of 4 can be. So these cancel. You're left with x plus 9 fourths equals plus or minus rad 41 over 2. Let's minus 9 fourths minus 9 fourths. You get x equals negative 9 fourths plus or minus rad 41 halves. That is one of the answers that I will accept. Negative 9 fourths plus or minus rad 41 over 2. Make sure it's over 2. Square root of 4 is 2. The other value you could have done is you could have found a common denominator. And the other value is you would have multiplied this by 2. So you could have negative 9 plus or minus 2 rad 41 over 4 is the other answer. Probably the answer in the back of the book or in the answer sheet. But this is just as good. Both of them will be sufficient. Okay, they've already moved the constant. Let's take half of our b value and square it, which equals 9 fourths. So we're going to add 9 fourths to both sides. Let's write it this way. P squared minus 3p plus 9 fourths equals 88 plus 9 fourths. This gives us p minus 3 halves, quantity squared. 88 in fourths. 88 times 4, 32, 32, 35, 3, 52 over 4 plus 9 fourths. P minus 3 halves squared equals 361 fourths. That feels like a perfect square. P minus 3 halves squared equals plus or minus square root of 361 fourths. 361, I think it's 9. Is it 9? Now I'm becoming, or 19? I'm becoming familiar with 361. Before I'd never, 19 squared equals 361. See what happens when we do it. We add another perfect square that we start recognizing. P minus 3 halves equals plus or minus 19 over 2. Don't forget to square root the denominator. Add 3 halves. P equals 3 halves plus or minus 19 halves. 3 halves plus 19 halves. 3 halves minus 19 halves. That's going to give us 22 halves, or 11. This gives us negative 17? No, 16 halves. Hello, Mr. Mac. Slow brain this morning. Negative 8, 11. Did I write the solution set of that other one? Yes, I did. Oh, so completing the square. So a has to be, so let's divide everything by 2 first. Let's get rid of my a value. Let's make my a value 1. So that gives us a squared minus 11 halves a plus 5 halves equals 0. Woo boy. Let's move the constant. We can do fractions. You shouldn't be intimidated by fractions. Fractions are just fractions. They're just numbers, just like whole numbers. So we're going to take half of my b value and square it. Well, half of 11 divided by 2 is just like 11 halves times 1 half, which is negative 11 fourths. So this equals negative 11 fourths squared, which equals 121 over 16. Okay. 121 over 16. 121 over 16. This is easy. We've already done the work. This is half of my b value, 11 fourths, not 11 halves. We have to take half of it. So that was easy. We've already done the work. If we show our work, we have it to refer back to. And now times 8, so negative 40 sixteenths plus 121 sixteenths. That didn't slow me down. Hopefully it didn't slow you down. And what's that going to give me? 81? 81. Oh, yes. And once I said the word 81 sixteenths, I said, yes. Those are perfect squares. Told you sometimes they can work out nicely. Plus or minus square root of 81 sixteenths. You have a minus 11 fourths equals plus or minus 9 fourths. Let's add 11 fourths, add 11 fourths. A equals 11 fourths plus or minus 9 fourths. Now we do both of the statements. 11 fourths plus 9 fourths, 11 fourths minus 9 fourths. That gives us 20 fourths, or 5. This gives us 2 fourths, or 1 half. 1 half, comma 5. Cool answer. I like it. Wow, we're just keep going. How many of these? Who cares? We're comfortable with it. I'm going to move my constant so I don't have too many fractions. 3k squared plus k equals 10. I'm going to divide everything by 3. K squared plus 1/3 k equals 10 thirds. I'm going to take half of my b value and square it, which gives me 1/6 squared, gives me 1/36. So I'm going to add 1/36 to both sides. K plus 1/6 squared equals 10 thirds into 36 is 12, so 120 over 36 is 10 thirds, right? 3, what did I say? 3 times 12. 10 times 12, yep. Plus 136, we again should get excited. We have 121 over 36. That's a perfect square. Now we're going to take the square root. K plus 1/6 quantity squared plus or minus square root of 121 over 36. K plus 1/6 equals plus or minus 11/6. Minus 1/6 minus 1/6. K equals negative 1/6 plus or minus 11/6. Negative 1/6 plus 11/6, negative 1/6 minus 11/6. That's 10/6, which reduces. You must reduce all fractions. 5 thirds, negative 12/6, which is negative 2. Our solutions are negative 2, comma 5 thirds. Cool. Oh, more. How many examples are you going to have, Mr. Mac? A lot, apparently. Okay, this is already constants move. Let's divide by 6. Divide by 6. we get v squared minus, we can simplify that. 3 goes into that, 5 halves v equals negative 3 halves. Let's make sure that we did it correctly. Yup. So negative 5 halves is my middle. Let's take half of that squared. Gives us negative 5 fourths squared equals 25 sixteenths. Let's add 25 sixteenths. Add 25 sixteenths. And look, all these problems, the more problems I do, the more proficient I become, the better at it I become. And I shouldn't be afraid of that. 2 times 8 is 16, so negative 3 times 8 is negative 24, plus 25 sixteenths. I should get excited about that because that gives me 1 over 16. Take the square root, plus or minus square root of 1/16. V minus 5 fourths equals plus or minus 1/4. And all of these have worked out quite nicely. Add 5 fourths, add 5 fourths. V equals 5 fourths plus or minus 1/4. 5 fourths plus 1/4. 5 fourths minus 1/4. And me writing messy doesn't help the situation. That's where I might make a mistake. I might misinterpret a number. So it is in my best interest, 1 comma 3 halves. 3 halves is bigger than 1. Yes! Woo! On to part 4. All right, we got to solve the equation with quadratic formula. The only thing you need to remember is A must be positive. It can be bigger than 1. It just must be positive. My hands are... It's because writing on this tablet thing, I have to keep my elbow up. And so my left shoulder is absolutely burning. So... must be positive, and our formula is it's derived from ax squared plus bx plus c is where we get it, so we have to set it equal to 0. A must be positive. Let's do this. Set equal to 0, and so my a value is equal to 6, my b value is equal to 5, and my c value is equal to negative 4. We're going to plug it into this equation. The quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of my b value plus or minus the square root of my b value squared minus 4 times a times c all over 2 times a. Negative 5 plus or minus 25. I'm going to get a positive value. 24 times 4, I don't know. 24 doubled is 48. 48 doubled is 96. 96. Because I didn't write it down, so I could write it down. I could do 24 times 4, which is 16, which is 896. I don't need a calculator. Times 12. Negative 5 plus or minus. That gives me 9, 10, 11, 12, 121. We like that. So we should really be recognizing perfect squares way more often. And now this turns into two statements, negative 5 plus 11 over 12 and negative 5 minus 11 over 12. This will give us 6 over 12, which simplifies to 1/2. This will give us negative 16 over 12, which simplifies to negative 8/6, which is negative 4/3. So I have 1/2 negative 4/3, So negative 4/3, comma 1/2. Wow, I opened up with a nice one. No whole numbers to start with. So here's an interesting one. So let's set it equal to 0. We haven't done one of these, so this will be good for you to see. Plus 40 equals 0. So let's factor out the negative 1. Leaving us with p squared, we'll take a negative, makes positive 6p. Take a negative, makes negative 40 equals 0. And now let's divide it by negative 1 to get rid of that negative, leaving us with p squared plus 6p minus 40 equals 0. So now it's in standard form. My a didn't need to be 1. It just couldn't be negative. So I just got rid of the negative there. So my a value is 1. My b value is 6. My c value is negative 40. Opposite of b, plus or minus square root of b squared minus 4 times a times c, all over 2 times a. Negative 6 plus or minus 36. Negative is a positive 160 over 2. Negative 6 plus or minus, that's 196 over 2, which is perfect square also. Negative 6 plus or minus, is that 16? 16? I think it's 16. 16 squared equal, no, not 16. How about 14 squared? 196. Plus or minus 14 over 2. Let's write the two statements. Negative 6 plus 14 over 2. Negative 6 minus 14 over 2. Do the work. That gives us 8 over 2, which is 4. This gives us negative 20 over 2, which equals negative 10. Negative 10, comma 4. Set them equal to 0. We'll move the negative 2 over, move the 3x over. Write it in standard form because your a, b, and c are derived by your standard form. A equals 2, b equals negative 3, c equals negative 2. The opposite of b, plus or minus the square root. You better have that b in a parentheses if it has a negative. Minus 4 times a times c, all over 2a. That's 3 plus or minus 9 plus 16 over 4. 3 plus or minus 25 over 4. 3 plus or minus 5 over 4. Okay. 3 plus 5 over 4. 3 minus 5 over 4. 8 over 4 equals 2. Negative 2 over 4 equals negative 1/2. Negative 1/2, comma 2. Nothing weird about this. A equals 1, b equals negative 3, and c equals negative 7. Opposite of b, plus or minus square root b squared minus 4 times a times c, all over 2 times a. 3 plus or minus 9 plus 28 over 2. That's a horrible 2. 3 plus or minus, what's that, 37 over 2. And there's our problem. Well, that's not our problem. Rad 37 cannot be simplified, so you just get something that can't be simplified. That's your answer. That wasn't too bad. Ooh, I like this. Set it equal to 0. This is a good one. Minus, what's that, 19? Yeah. Ooh, 19, really? Yeah, 19. Okay, what's my A value? My A value is 1. What's my B value? My B value is 0. There is no B. B is the coefficient of our linear term, our n. There is no n. And then my C value is negative 19. Opposite of B, so it's the opposite of 0, plus or minus the square root of 0 squared minus 4AC. Ooh, this should be a little hint here. 2 times A. Watch this. Watch this little trick here. So you have 0 plus or minus square root of 0 plus 19 times 4, 36, 76, right? 9 times 4 is 36. Yeah. 76 over 2. You have 0 plus or minus rad 76 over 2. Now the question is, hey, can I simplify rad 76? I already knew I could. Because how did I get 76? By multiplying 4 times 19. So I'm going to break this into rad 4, rad 19, giving me 2 rad 19. So that was something you had to pay attention to the detail there. So we get 0 plus or minus 2 rad 19 over 2. So writing the two statements, 0 plus, wow, 2 rad 19 over 2 and 0 minus 2 rad 19 over 2. Well, this is going to give you 2 rad 19 over 2, which cancels. They're being multiplied so we can cancel. That gives me rad 19. This gives me negative 2 rad 19 over 2. And that gives me negative rad 19. So my answer is plus or minus rad 19. It is an interesting one. That's a good one. Hopefully you made it this far into the video to see that problem, because that'll be very helpful to you. 3n squared minus 12n minus 4 equals 0. A can be greater than 1. It just needs to be positive. So my A value is 3. My B value is negative 12. And my C value is negative 4. The opposite of B, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. Oh, my hands are killing me. 12 plus or minus 144 plus, that's 12 times 4, which is 48, all over 6. 112 plus or minus, that's 188. Ooh, over 6, 188. 188. Okay, 4 goes into that 47. Let's just check. We can do it and check. 4 times 47 gives me 188. That was correct. So we get 2 rad 47. So 12 plus or minus 2 rad 47 over 6. Now, I can simplify this. I can simplify it because each of these terms have a common factor. All 3 must have a common factor. So I can divide each one by 2. This gives me 6 plus or minus rad 47 over 3. Do not cancel this 6 and 3. They cannot be simplified in this format. Now, the other answer you could do You can put the 3 under both of them. And that can simplify to 2 plus or minus rad 47 over 3. That is the other answer you can have. Most people are going to see this, but this is also acceptable. Good. Those are your only 2. And that's it. Woo! I like not knowing how many problems, because when I'm done, it was so exciting to know. Okay. Nice job. That took maybe an hour to do, but you're well versed, you're practiced, you're going to get 100 on the test on Tuesday. Good job. Way to make it this far. Congrats.